Now, so we're recording, okay? Now, this is two broad topics. So, put the topics here on the top. So, exam objective 2.1, declare and initialize variables, including 2.3, yeah. This is exam objective 2.1 from the board document we have, including testing of primitive data types. So exam objective 2.2, differentiate between object reference, variables, and primitive variables. Yes, this is section 2.3, Kathy. It's a new Java project. And I've uploaded section 2.1, so that's fully there now. Just the main at the moment. It's just a main and it's section 2.3. Now we're going to create a dog class, please. Okay, so now inside the dog class we're going to have a static int counter. Now what's this guy going to do? This is going to keep a count of how many dogs are created. Right, this is what this guy is going to do. I'll explain in a minute now. Int age is equal to 45. Double weight is equal to 12.34. And just to make things a bit awkward, I'm going to make final int dog ID. Now, so every dog will have a unique ID, which we will make final, which means when a dog has been assigned an ID, you can't change it.
It doesn't like the no ID if on the way.
Yeah. Now, why am I getting an error there to start talking? Yeah, that's exactly what's wrong with it. Okay. You can't allow a situation where a final is not initialized. So what we're going to do is we're going to only have one constructor in the class. So we have to initialize, we have to give an initial value to a final, or we get a compilation error. Now, we're not going to assign it here because we want every dog to have a different ID. Okay, we want a dog to have a different ID. So how are we going to do? We're going to do this. So we only have one dog constructor. So this is the only way we can create a dog. Now we have to give a value to the final int dog ID in this constructor. Okay, so we have to give it a value. We have to give a value to dog ID inside the constructor. So the constructor is public dog. Now, having a look at our code, all right? Can you see of any way I can give a unique number to every dog that's created?
You have counter.
Yeah.
So it's possible. You use the slash counter.
Yeah. Because what I show how we do. Okay. So if I go dog ID is equal to counter, and then I go counter plus plus. Now we're going to start the counter at 1.
Did you not put the counter plus before it?
No. You could, but I'm not going to. Right? So it starts off at 1. So our first dog created, let's say Spot the dog. Okay? So I create the dog called Spot. Now, so what happens inside here, dog ID, so the ID of Spot is going to be 1. Okay? The next thing that happens, it increments the counter by 1. So counter is now 2. But the ID of Spot is 1. We create a second dog, Rex. Okay? Dog ID is equal to counter. Now remember, it's a static variable, so it's at 2. Alright, so it's at 2. This is our second dog. So the dog ID is going to be 2. Then it goes counter plus plus. Counter becomes 3. So each dog is going to have its own ID, which is the amount. So that's the first dog created. That's the second dog created. Lassie is going to be our third dog created. So it's going to have an ID of 3. Okay. So this is an example of using a static counter to keep a track of how many objects have been created.
If you don't have a static, when you consider it like an int, would
No.
it's not be the same?
No, because then what's going to happen is each time you create a dog, the counter is going to be set to 1. Okay, so if I don't have a static in here, the easiest way is to show you. Right? So we'll create it and then I'll go back to explain it again.
Sorry, static is not like last created, like last counter.
Well, so this variable, okay, there's only one of them. Now, every dog has their own age. Every dog has their own weight. Every dog has their own dog ID. Okay, but all dogs share this variable. All right, and at the very start, when we create a dog, Spot. Okay, so counter is set to 1. Now the first thing that happens when we create Spot is that it assigns whatever this original value was to Spot. So the dog ID of Spot is going to be 1.
No, I understand it, but I mean, static it's new at last user like counter. Like if we will change like 5 dogs will be,
Yeah.
so it will continue from last. Like why it's static? Yes.
Yeah. Well,
Static, it's always
it doesn't continue from last. It's that. So let's say if I create Rex, Lassie. Now, so the way it would work is that Spot with an ID of 1, Rex would have an ID of 2, Lassie would have an ID of 3. Okay, that will be their IDs. Now, So if I go spot.dogid, it'll print off 1, rex.dogid, it'll print off 2, lassie.dogid, it'll print off 3. Alright? Now, if I go spot.counter, that's going to be 4. If I go rex.counter, that's going to be 4. If I go lassie.counter, it's going to be 4. Reason being is because the last dog I created Lassie. So go to Lassie here. So dog ID is equal, so it becomes 3, and then it increments the counter by 1. It becomes 4. So the counter, it's a static variable. It's a class variable. It's set to 4, and what that is, that's the amount of dogs created. All right. To even prove it works that way, we're going to create 3 dogs.
Static here.
No. What I'm going to do is I'm going to create 3 dogs, and I'm going to show you how it works as it's static, and I'm going to show you what happens if it isn't static. Okay? So, now, and where am I? Right. So I'm going to go dog spot is equal to new dog. I'm going to go dog rex is equal to new dog. I'm going to go dog lassie is equal to new dog. Right. Now, I'm going to the ID of spot is plus spot dot dog ID. Yes. Yeah. So, ID of rex plus rex dot dog ID.
I get ID in all of them.
Yeah, but just leave it minute on minute. ID of lassie is plus lassie.dog ID. Now, so I have the ID of spot is 1, ID of rex is 2, ID of lassie is 3. Okay, and just to show you, they all have the same counter. Okay, so if I go spot dot counter, if I go rex dot counter, if I go it all prints off 4. Everyone with me so far, yes? Now, every dog has their own ID. Okay? Not every dog has their own counter. There's only one counter variable. Alright? There is 3 dog IDs. It's a dog ID for each dog.
Oh, I think that a counter not the
Yeah, that's the problem. Okay? So, there's 3 dog IDs, 1 dog ID for each dog. Right? There is only one counter variable shared amongst the 3 dogs. So what you're doing in the constructor is so what we're doing in the constructor is each time we create a dog, we're adding 1 onto the shared variable counter. Okay? So it starts off at 1. The shared variable. Static variable, it's a shared variable. Starts off at 1, it assigns 1 to dog ID. And then spot increments the shared variable by 1, so it becomes 2. So after the first dog is created, counter is set to 2. We create our second dog. Alright? So it assigns the number 2, which is what the shared variable counter was, and assigns it to dog ID. The next thing it does is the shared variable counter is incremented by 1, so it becomes 3. So that means that after Rex, okay, if, in actual fact I'll show you. Right, in here, I'm going to say counter of spot is now spot.counter. And I can say counter of Rex is now. Right. What will I print off? 3 for both of them, because it's the same variable. Okay. And what happens when we go? It assigns 3 to Lassie, and then in the process of creating Lassie adds 1 onto counter, so it becomes 4. So a static variable is an easy way to keep track of how many objects have been created. Alright?
But the other thing is like what happens if you understand when the program gets to a for loop and it goes like +1, +2, +3 every single time it iterates.
Yeah, but there's no loop here.
There's no loop here.
No.
Basically the software is starting, it's holding
It's
that variable.
right now. It's starting at 1.
It is starting at 1, but the whole program, like, so when it's
Well,
starting,
yeah, but every time we create a dog, it's adding 1 onto that.
So in order to do that, we need to remember that the previous one was this.
Doesn't need to remember the previous one because there is no previous
How's
one.
the order of things
There's
there?
only one of them. There's only one counter. That's only a shared variable.
So
So
it's the constructor that it creates it.
it's the constructor that keeps adding 1 onto that. Every time we create a dog, it adds 1 onto that variable. And
I realized that was the thing.
it's shared. It's shared. Okay, that's a shared variable. Okay. Every dog is gonna have their own age. Every dog is gonna have its own weight. So if Spot changes his age, it's not going to affect Rex's age. Okay. Now, if Spot changes the counter, it's a shared variable. That means the counter is changed for all of them. Do you understand that? If Rex changes the counter, it's changed for all of them. It's like if I came along and changed the course ID for this course, that means the course ID is changed for everyone in the class. It's just a variable that applies to everyone.
If you take out static,
If you take out a static, everyone is going to be 1.
is it?
Yep.
Even though we did the implementation in the software.
Yeah, but you see, that's all that's going to happen is the next time another dog comes along, it starts off up here and puts counters equal to 1. To even prove it.
Okay,
Yeah. So if you don't make it static, it means that every dog is going to have an ID of 1. Okay. So just guess.
I thought the counter starts at 1. I thought I implemented.
No. Okay. Because you could construct your class in such a way that one variable affects another variable in another class, but it makes things too awkward. Okay, so it's a static. Static is a class variable. It's a shared variable. There is only one of those. Doesn't matter if you've got 1,000,000 objects created. There's only going to be one counter. If you have 1,000,000 objects created, that number is going to read 1,000,000. Yeah. What?
Let's say in this class we will create subclass.
Yeah.
Like calling and always, and you want another counter, so we need to add to.
But but you remember that if you're going to have a subclass of dog, it's always going to look for a super constructor in the dog class. Okay, so this is still going to be incremented. So let's say class Siamese, not Siamese, collie, extends dog. Okay, if you create a Siamese, you're also incrementing this guy here. Okay, so just to prove it, if I create me a collie, sorry. So if I create me a collie hunter is the new collie. Right? Now, hunter is a collie is a dog, so he's going to have a dog ID. So that means it's called a constructor in the dog class, which is incremented the counter by 1. So hunter has an ID of should be 4. So hunter dot dog ID. Okay. And now that means that counter is now changed to 5. So if I go hunter.counter, rex.counter, lassie.counter, that's what I have to do here.
Sorry, but you need another counter. Let's say would be like 4 from dog, and let's say 1 from collie.
All you need to do then, so all you do is simple as this: static int collie counter, and you go collie, and all
So
you
we
have to
can have more counters.
you can of course, yeah,
Different class.
collie counter plus plus, and you can even do something like dog ID. Right, I wouldn't do that. Right, so here you can get a count of the total amount of dogs created and the total amount of collies created. Alright, the dog constructor will still run, so it'll still say 4 dogs have been created, but you now have 1 collie created as well, so you can say 4 dogs and 1 of those dogs is a collie. Okay, so you can have as many counters as you want. So statics are very, very useful for, first thing, for keeping account of the objects created. Also, you want some way to identify the objects that have been created. Alright? Let's say you're creating 50 identical dogs. You want somehow to uniquely identify each dog. Okay? You are going to want to do this. Okay? Particularly when you come to databases, there's something called a primary key. A primary key is something that uniquely identifies a dog.
Are we doing databases in this work?
We will be doing a small bit, yeah. Not on the exam.
Is it?
No, it's not. Okay. Now, by using this ensures that every dog is going to have a different dog ID. First dog is going to have an ID of 1. Second dog is going to have an ID of 2, an ID of 3, an ID of 4, an ID of 5. Okay? You should always have some sort of unique identifier for every object that's created. The simplest way to do it is with the static. Okay? Now you can put in, if you wanted to do the alphabet instead, you can do that to give someone, let's say, a dog starts off with A, B, C, D, E, F, G.
So instead of counter equal 1, we can add like counter equal 8.
Well, what you would do, well, for certain, no, A, B, C, D, E, F, G isn't good enough, because when you get to 26, then what do you do? Do you understand what I'm saying?
A1, B2, 1, B2.
Now, of course, a way around that, one way around that is to make them, numbers is better. Okay.
But can we use like
Yeah.
But this will be int or char.
It'll be a char, but remember a char is an int. Remember 67 is capital A. So 68 is capital B. Okay. So if you know what A is, think that's the way anyway. Let me just check. I think 67 is A or B or one of those. Let me just see what it is. Char is equal to 67. C. So that means if 65 is A. Okay, so all you have to do is, if you go just do a quick for loop there. 2 0. There we are. See what's happening there? Go down here. Starts off at A. Then it goes on to B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. Okay.
You know the way you have to stop it there?
Yeah.
I mean, you have to have a check. Would that not get in the way of initialization?
Say that again now. If it goes for Z, yeah?
You can only go for a Z, which means you have to actually have a check and construct.
You would, yeah.
No, and that would get in the way of initialization.
Yeah. Well, what you'd have is, if you didn't want to go beyond Z, you can't create any more than 26 dogs. So you keep a count of the amount of dogs created.
Yeah.
So if there's more than 26 dogs created, you'll say we can't
Just the
create any more.
existence of that check is blocking the initialization.
Of
Of it being assigned a value to you, that check is a rule.
oh, you mean the final then can't be initialized because of that check? Yeah. That is going to cost. Yeah. So what you could do, you could do something called a static initializer. You could do initializer up here. Initializer run before.
Oh, yeah.
Yeah, you could put initializer above the final, and so the initializer will do your check. And if it fails the check, it just won't go any further. That's the way around it. Alternatively, this will go 20. There's nothing stopping it going to 100. Now, then it goes to different symbols. See all these? Right, so some of them they can't display. So when it gets to Z, it goes to square brackets. Then it goes to lowercase A, B, C, D, F, G. Then it can't display these. Okay? Because I don't have the correct character fonts installed for them. Alright? So, yes, you can do chars like so. Okay? Now, but if you are going to use, let's say if you're going to use something like a PPS number, a simple just going up in characters is not going to work. A simple going up in numbers is not going to work. You'll want some sort of formula that calculates the number and the letter. Okay? That formula it used to be publicly available. There was a formula for calculating your PPS number up until 6 years ago, believe it or not. You could get if you got all your personal details, you could generate your PPS number. Okay? They didn't think of it. It was a combination. I can't remember what the variables was, but I remember I was teaching a class before and we did it in Excel. We tested, we got all our details and I got our PPS number back. So I think it's prior to all PPS numbers issued in 2010, I think. There is an issue. Alright? 2010, yeah.
Or how will this year?
No, 2010. Okay. So
all of us.
Yes. Okay. Now, so what's happening? Yeah. Yeah.
If you were getting the ID for a hunter,
Yeah.
you have two references there, don't you?
Yeah. Well, you see, yeah, but all the collie counter is doing It's just counting how many collies I've created. Okay, I should start off at 0. So all that's doing is keeping the count of the collies. Okay, it's not assigning the counter to the dog ID.
If you use collie ID, then you put collie ID, you can counter the dog.
Yeah, but the problem with that is, then you could have a dog with ID 1, and then you have a collie that is a dog with also ID 1.
Yeah.
So there'd be a conflict. Do you get me? So we're using this guy here to assign the ID. And that means a collie is going to have an ID. And it's going to the same ID. If there's 50 dogs created, if he's the 50th dog, he's going to have an ID of 50. If he's the millionth dog created, he's going to have an ID of 1 million. Is that okay? Right. So, let's go back to this here. So, every time we create a dog, we are incrementing a static counter variable by 1. Okay, that means every new dog we create, this counter variable is assigned to be the dog ID of each dog. Okay, this counter keeps track of how many dogs are created. So this means that our first dog created will have a dog ID of 1. Our second dog created will have a dog ID of 2, etc., etc. After 4 dogs are created, counter for all dogs will be set to 5. Okay? So ID of this dog, 1. Dog ID is 2. Dog ID is 3. Okay, counter is the amount of dogs created plus 1. Now what I mean by that is I created 3 dogs. And after we create our last dog here, it sets the counter to 4. Okay, so if you have 3 dogs, the counter is going to be 4. If you have 1,000,000 dogs, the counter is going to be 1,000,001. Do you understand that? Okay. So this guy here, this is going to read 3. So 2 dogs created at this point. So counter is 3. So spot.counter is 3, rex.counter is 3. We create a dog called Lassie, or Lassie.dog ID. That ID is going to be hold on a minute now. Oh yeah, sorry. Sorry, take that out. There's 3 dogs created at this point. Sorry, 3 dogs created at this point. So counter is 4. Lastly is the last dog created. So spot.counter will say 4. Rex.counter will say 4. Okay. Spot.counter, rex.counter, lassie.counter. Is that okay?
Mm-hmm.
Alright, seeing as people are gone for a fag, I suppose we take a break. Okay, so we'll check something here. Done here. Now, I want you to create a class called Zebra, please. Create a class called Zebra.
Yeah. Morning.
Okay, so create a class called Zebra, please.
So it's 2.3, isn't it?
Yeah, it's 2.3. A public class Zebra. And the internals of it, I want you to have the same as dog. So static int, counter, int age, double weight. Okay, those 3. And then we go final int id, and we create a Zebra constructor where, oops, sorry, hold on. ID is equal to counter plus this. So every Zebra is going to have a different ID. Okay, just to put it in here, this cannot be changed and has to be given a value. The ID will be the current count. So if 2 zebras created, the first zebra will have an ID of 1, the second zebra will have an ID of 2, etc., etc., etc. And we're going to create 2 zebras. So come back to me. Okay. We're going to create 2 zebras. Zebra Z is equal to new zebra. So it means that zebra is going to have an ID of 1. And we're going to have zebra Zelda is equal to new zebra. So this one is going to have an ID of 1. It's going to have an ID of 2. Now, so what we're going into here is something called testing for equivalence. Alright? Now we're testing to see if they're the same object or we can override the equals method. Alright? So we're going to explain this. First of all, we're going to go int num is equal to 45. Int num2 is equal to 45. Now, if I do this, so what you're testing if two numbers are the same. It's this guy. It's num equals num2. Okay, it's not this guy, right? That's what it's not. What is that doing?
What's value num 2 into num 1?
Okay, so that means that num2 and num1 are now the same value. Okay, they're the same value. They're the same value anyway. Okay, so it's actually doing nothing there really. Okay, so this is testing to see if they're the same value. Okay, so that will return true. Everyone okay with that? Yeah?
Yeah.
Right. Now, I am going to create a third zebra up here. Zebra zo is equal to new zebra. Okay, an ID of 3. Actually, sorry, zebra zo is equal to z. Okay, zebra zo is assigned to z. That means that zo and z are the same zebra. Does everyone understand that? Yeah? So, zo and z are the same zebra. So, this is a brand new zebra with the ID of 1. This is a brand new zebra with the ID of 2. We create a zebra reference, another zebra reference to z. That means z and zo are the same zebra. They both have an ID of 1. Okay, the same zebra, yes? We all understand that?
Yeah.
Z and zo are the same zebra. That zebra which is an ID of 1. Yes? Okay, right. Now, so if we do this, so if we say testing for equivalence. Okay, so what we're doing here is we're going to go zo equals z. Now, what that does is that checks to see are zo and z the same object. Okay, they're checking to see is the reference zo and the reference z, are they both pointing to the same object? Okay, and yes they are, so it'll print true. Yes?
True.
Do you understand that? That is testing so zo and z are the same zebra. So they're asking me there, are zo and z the same zebra? One person calls it zo, another person calls the zebra z. It's the same zebra with the ID of 1. Yeah? Okay. Now, so just like this one, we can say z equals Zelda. Okay, that'll be false because they're two different. False because two different zebras. Okay, true as zo and z are the same zebra. Okay, now what I'm going to do is I am going to change aspects of Z and Zelda. Okay, I'm going to change aspects of Z and Zelda. So I'm going to give Z that age is going to be equal to 3. Okay. and I'm going to go Zelda.age can be equal to 3. I'm going to go Z.weight is going to be equal to 2.3, and we're going to go Zelda.weight is equal to 2.3. Now, so these are two dogs. These are two different dogs, but all of the attributes, bar their ID, are the same. Yes? You understand that? Okay. So these are two zebras that have the same age and the same weight. Everyone with me so far? Yeah. Right. Now, if I come along, if I did Z equals Zelda, it's still going to be false. Yes, because they're two different zebras. Okay. Now, if you're testing to see are two objects the same, you usually don't use this. Okay. What you usually use for objects is this guy. It's equals. Okay. So now, so I'm going to put it in here. If we don't override equals method, all this does is check if if Z and Zelda are the same zebra. However, now what we want to do is we're going to override this. Okay, we're going to override this to check that if they're twins, it's going to return true. All right. Now we can see here that they've got the same age and they've got the same weight. So that means that they're twins. Is that okay? So we're going to override the equals method to check if they're twins. Now they have different IDs, so they're two different dogs. But that's not what we're asking the equals method to do in this case. We're asking the equals method to check do we have the same age and the same weight. Okay? I'll put that down here. However, we want to check if they have the same age and weight. So we override the equals method that checks if the two dogs have the same age and weight. If they are, then it's two zebras. If they are, then this will return right. So now we are going to go to the zebra class and we're going to override the equals method. Okay, so we're going to go to here. Now, so the object class has an equals method. So the object class, so every class, remember, inherits from the object class. All right, and the object class has a method that looks called equals that looks like this. It's public boolean equals object my zebra. Now, so we have an error there because this returns either true or false. Okay, and we don't have a return statement in there yet, but we're going to do now. So I'm going to write in the comment here. So, now, object is the superclass of all other. Sorry, just get rid of this bullshit. Sorry. in Java. And ultimately, all classes are derived from this class. Okay? There is a method in the object class called equals. Okay? If you do not override this method, it will return true if the two object reference you are comparing are the same object. Okay? So if you compare two zebras, if they're the same zebra, it's going to return true. If you compare two dogs, if they're the same two dogs, it's going to return true. Okay? Now, this method takes a object. So when you have a superclass object in a parameter list of a method, it means that this method can take any subclass of this object. In this case, it's an object, which means it can take any object of any type. Okay, so you can create something called an object. All right, there is a data type in Java called object. Now, object is the superclass of everything else. Now, when you have a superclass object in your parameter list, that means that method can take anything that's a subclass of object. It can take object or anything else. That means, so it's gone blank. That means that this method can take any object. If this was animal, now it won't work. That was animal. That means that this can take an animal or any subclass of animal. Do we understand that? Okay, so the equals method in the object class, it's public boolean equals object. Now it doesn't matter what you call it. Okay, it doesn't matter what you call it, that doesn't matter. So when you're overriding it, you have to put in the same, the parameter list has to be the exact same. The name has to be the exact same. Okay? For now, we'll say the return type also has to be the exact same. Right? So that's what the method in the object class looks like. It's going to say a public boolean equals object. Okay? And here we're choosing to override it. Now to prove that it's overriding, I put in that guy. Alright? That just checks to see is it overriding. If it wasn't overriding, you'd get an error above it. You get an error there. Alright? Now, so what we're going to do is now this is the zebra class. Alright? So we call this method with, let's say, z dot equals Zelda. Okay? Now, we know for a fact we're inside the zebra class. Okay? The only thing that's going to call this method is another zebra. Okay, that's the first thing. Right? So we know a zebra is going to call this method. Not going to be a dog, it's not going to be a cat, it's not going to be a person. It's only going to be a zebra that's going to call this method. Okay? And we also know that what's going to be sent to it is also going to be a zebra. Alright? The way it's constructed at the moment means that only a zebra can call this method and only a zebra can be sent to this method. Yes? Do you understand that? Because it's inside the zebra class. Okay? It's inside the zebra class, so nothing else can call it. Yes? Okay? So, we have here, now, this guy here. So, when you create the method, what you have is an object reference to a zebra object. Okay, what you have is an object reference to a zebra object. Now, that means any variables of the zebra class you do not have access to. You do not have access to the age of the zebra. You do not have access to the weight of the zebra. And what we want to do, we want to compare the age of both zebras. We want to compare the weight of both zebras. Yes? Do you understand that?
If it's have no access,
Sorry?
if it's have no access, so how we can compare?
We do have access.
You said just like a line.
No, we don't have access at the moment. Okay? Because it's an object, a superclass reference to a subclass object. That means that this particular object here, which is Zelda, okay? We know it's Zelda. So it's an object reference to Zelda. Okay? It's an object reference to Zelda. Now the object reference only has access to methods and variables first created in the object class. Okay? So it does not have access to age. It does not have access to weight. However, it is a zebra object. Okay? So that means we can cast it. We can change the reference to be of type zebra. Okay? We can change this reference here to be a zebra. So if we change the reference to zebra, that means we have a zebra reference to the zebra object, Zelda. That means we then have access to age and weight. Does that make me so far, yeah? Okay. So,
That's the overriding because you're using a superclass and a subclass.
it's not really overriding, it's just revealing stuff. Okay?
Yeah.
Because when you have an object, so
Overriding has to be exactly the same.
yeah, overriding is about methods.
Yeah.
References don't override. Objects and references don't override. It's called.
The parameter in this would be, you're talking about one case you talk about a superclass, and the next one you talk about a subclass. One the reference like the actual object there, and
Right. So Z equals Zelda. Okay. So Z is calling this. Okay. So Z is calling this. So my zebra is Zelda. Yeah. Right. Now, but it's an object reference. Okay. Which means this is exactly what it looks like. Object my zebra is equal to Zelda. Alright? Now that means it's only showing the object parts of Zelda. Okay? You don't have access to the age, you don't have access to the weight, you don't have access to the ID. Why? Because they weren't first created in the object class. Okay? What references allow you to do, it allows you to only show certain aspects of an object. Okay? If you want to get access to the age, if you want to get access to the weight, you have to change that reference to a zebra. Okay? Now, how you change something is casting. Casting you can only do if it's a compatible data type. Okay? That means that what's on the right hand side if you want to cast it, you have to be able to cast it this side. Now, it's a zebra on the right hand side. So that means you can change the reference to be a zebra. Okay? So we change this from an object reference to a zebra object to a zebra reference to a zebra object. That then entitles us to access to age and weight. Okay? That's why I was going on about yesterday how you can have a superclass reference to a subclass object. You can have an interface reference to a class that implements that object, or you can have the same reference type and the same object type. Okay? So things are never straightforward. Alright? Now, so Z calls the method, and we know that this object, it's an object reference to a zebra object. That means we can cast it to be of type zebra. We can change the reference to zebra. Okay? And how we do that is the following. We just go here, we go zebra, new zebra is equal to zebra my zebra. Now, what that's doing, never mind, we still have an error there. The reason we have an error there is because we haven't put in the return statement. So I'll just put in the return statement at the end. Alright, so just, right, now, so what this does is the following. It creates a new zebra. Alright, but this zebra, so I'll create a new zebra called, so it's a zebra, new zebra. So it's this guy. So it's casting my zebra, which is Zelda, which is an object reference to a zebra object. This changes it to a zebra reference to a zebra object, which is Zelda. Okay, so
just change the input the argument itself, please.
Because then what you have in that situation is the following. So if you just do this, you're going to have a subclass reference to a superclass object, which you can't have. That.
No, I mean the actual argument itself, that the equals not is taken in. Instead of taking an object, we're not just taking the zebra instead.
Because with overriding it has to be the exact same. Okay, the return type can be a subclass, but when you're overriding it has to be the exact same. So it has to be an object. Is that okay? Yeah, right. Now, so zebra my zebra is equal to zebra my zebra. Alright, now that means, because we have to compare two different zebras, alright, we have to compare the age and weight of one zebra against the age and weight of another zebra. Yes? You understand that? So what we're doing inside here is, inside the method, we create a brand new zebra. Okay? The brand new zebra is a zebra reference to a zebra object. Okay? What's the zebra object? It's Zelda. Okay? We send Zelda to it, but when we send Zelda to it, Zelda was an object reference to a zebra object. What the casting does here is that it basically changes Zelda to a zebra reference to a zebra object. So now you have access to the age and weight of the zebra. I know this sounds very, very complicated. Alright? But believe it or not, it just follows rules. It all follows logic. Okay? It takes a bit of getting used to. Right? We're not actually doing anything new here. It's just an extension of the rules that are already there. That's one good thing about Java. If you know a little bit of information, you can work it out. Right? Even though you've never seen code before, you can work it out. It's different from something like PHP or JavaScript, where there's 1,001 rules and each one of those rules to be broken. Okay, with Java there's very strict rules, so if you know only the basic rules, you can actually work things out. Okay, so this means that new Zebra is now, this is now Zelda. Okay, new Zebra is Zelda. And we have access to the age of Zelda. We have access to the weight of Zelda. Does everyone okay? Everyone understand that? Yes? Okay. Z is the person that's going to be calling this method. Zelda is this one. Everyone okay with that? Do you understand what I'm saying? Z is calling this method. Go back to it again. Z is calling the method. Zelda is the one that's been sent to us. So we're comparing Z against Zelda. We want to compare the ages and the weight. If they have the same age and the same weight, they're going to return true. Okay? And go here. So, and inside here, because when we send Zelda to it, because it's overriding the equals method in the object class, you have to say it's Boolean equals object. Okay, so that means that Zelda has an object reference to a zebra object. That means we don't have access to the age and the weight. So in order to get access to the age and the weight, we have to cast that object to be of type zebra. So it's only after this point have we access to the age and the weight of Zelda. Now that means that inside here, age refers to Z's age, and my zebra dot age refers to Zelda's age. Do we understand that? We don't care what the answer is, right? That's not what we're trying to figure out here. We're trying to get the method working, right? We don't care if it's true or false at the moment. Okay, so age, because Z is the person calling this method, or Z is the zebra calling this. So age inside here refers to the age of Z. My zebra.age refers to the age of Zelda. Yes? Okay. Similarly, if we just have the word weight inside here, this refers to the weight of Z. And inside here, if we have my zebra dot weight, that refers to Zelda's weight. Okay, so we're going to have to do a calculation that's going to return true if the age of Z is the same as the age of Zelda and the weight of Z is the same as Zelda. So I'm not going to ask you to do that because that's too difficult. So I'm going to do it out here. Okay? So it's quite simply an if statement. So I go if age. Now age means the age of Z. Okay? To my zebra, that age. Hold on a minute now. Why is that kicking me in? Why is that giving me an error there? Hold on a second.
He's dealing with this age.
No. Its age is equal to my zebra.age. I should be able to go my zebra.age. Oh, sorry, it's new zebra. Sorry. New zebra.age. Okay. So zebra, new zebra. So if age is the same as my new zebra.age, and now you can put in this dot weight. You don't have to. I could put in this dot age, but I don't have to. I'm just putting it in there to show you that it's referring to the weight of Z. So this dot weight is the same as new zebra.weight. So if Z and Zelda have the same age, and Z and new zebra or Zelda have the same age, it's going to return true. Okay? Else, it's going to return false. Okay? Now, I'm going to put the comment in here. So I'll put a comment directly above this to start off. When overriding a method, the name, return type, and parameter list have to be the same as the method you are overriding. Okay? So this method will take a zebra, but this will be a zebra object with a object reference, which means this object will have no access to the age and weight of a zebra. Okay? So we have to cast the object reference to the zebra object to be of type zebra, and then this object has access to the age and weight of the zebra. What was her name? Zelda. Okay. Yeah.
The notes will be, you could call that a different method, and then you could stick in the zebra reference instead of the object reference. So you
Here.
Equals 1, and then call it equals 1 on the.
Oh, here. Yeah.
You could get away without casting.
Yeah. I'm showing you this basic one first. And next one I'm going to show you is I'm going to let Eclipse do it automatically for me. Okay. Now Eclipse does something an awful lot more complicated. Alright. And it's more accurate, it's better. But this is a simpler equals method. All this is doing that if a zebra has the same age and has the same weight, the equals method will return true. Okay? Simple as this. So if both zebras have the same age and weight, this method returns true. Okay, so if they're the same age and the same weight, return true. Now, if they're the same object, it'll also return true. Why? Because if they're the same object, they're going to have the same age and weight anyway. Do you understand that? Okay, so if both zebras have the same age and weight, this method returns true. So I'm going to put this in here as well. Age refers to the age of the zebra calling this method, which is Z, and new zebra.age refers to the age of Zelda. So we're comparing two different zebras' ages. We're comparing two different zebras' weight. Okay? If they're the same age and the same weight, it's going to return true. So we're gonna test it out. Go back here to main. Now, Z has an age of 3. Zelda has an age of 3. Z has a weight of 2.3. Zelda has a weight of 2.3. Z calls the equals method on Zelda. That means that age is going to refer to the age of Z. Weight is going to refer to the weight of Z. And the method new zebra.age is going to refer to the age of Zelda. New zebra.weight is going to refer to the weight of Zelda. So this should return true. Okay?
Actually, all 3 zebras, it's one zebra.
No, they're not. That's
I tried you all were like 3
No.
and all 2.
No, so right, yes, because all 3 of them will be true. All right, because now the question is how many zebras do we have? We have 2 zebras. Okay, first zebra has an ID. Now the way to check if they're different zebras is their ID. It's not their ages. It's not their weights. Okay, the way to check if they're different zebras is their ID. Now that equals method. There's nothing wrong with it. But it doesn't, if you have 2 different zebras, if they happen to have the same age and name, it's going to return true, which might necessarily be a thing you want. It might be something you want, okay? It might be something you want. You might want to see which animals have got the same name. You might want to see which people have the same name, okay? So the equals method, there is no right or wrong way to do the equals method. There's only the way you want it to produce an answer. The answer we want to produce here is if they have the same age and name, it's going to return true. Okay? That means you can have 2 different zebras that have got the same age, that have got the same weight, they're twins. It's going to return true. So the equals method can be here in this situation. You want to find twins. Yeah? If any of you have relations, twins, this is a method for finding twins. Okay? I'm going to go back to it here. So this is returning true. Okay? Z. So inside the method, age refers to Z. Weight refers to the weight of Z. Zelda, that is new zebra dot age. Zelda is new zebra dot weight. And then all we're doing is we're comparing both of those. Okay, and if they're the same, it returns true, otherwise it returns false. Now we have 2 zebras created. Okay, we have 2 zebras created. Now if you check Z against Zelda, which is what we've done, they both got the same age, they both got the same weight, so those 2 are going to return true. Now if I check Zoe against Z, that's also going to return true. Now these are the same zebra, so that means they are going to have the same age and same weight, because you're just checking, they're checking the same zebra. Okay, so even though there's 2 zebras, for these 3 zebras it's going to return equals. No matter what combination you could do Z with Zelda, you could do Zelda with Zoe, you can do Zelda with Z. Doesn't matter what combination you do, all of them are going to turn out to be equal. Okay, but we have 2 zebras. Yeah?
No, the print statement, the last one.
Yeah. Down here.
If you could you put there, if you could set that super that equals, it would come up with false, wouldn't it? Because they're two different servers. Or can you
Yeah.
put super in there, yeah?
I don't think you can. No, you can't call super dot equals. No, you can't. No.
That's what I just
No,
said.
no, you can't. No.
You would turn, it would be false if you could.
Yeah. You can put super in the zebra class. You could do that. So I'll just take that out.
So what would the super do?
Well, it wouldn't work there.
What would it
Okay.
do? Sorry, just remind me.
Oh, super. It'll call the equals method from the object class.
Right.
Okay.
It would be.
Which we were going to do actually, which we are going to do in a minute. Okay. Z dot equals Zelda.
I just checked there, and you can overload it as well.
Sorry.
You can overload it.
Oh, you
as
can
well.
overload it, yeah.
Which means you don't need to cast it.
No. Yeah. But we'll do one step at a time.
Yeah.
Okay. That'll melt our heads entirely. Okay. Right now. So this is cat class or the dog class. Works fine. Okay. Now we are going to create a cat class. Okay, and in the cat class we're going to go int age, string name, double weight. Now I'm not going to do an ID for this one. Okay, now I'm not even going to create a cat, but we just have int age, string name, double weight, and we got this dot age is equal to age, this dot name is equal to name, this dot weight is equal to weight. I'm going to show you how to quickly create an equals method. Now if you go to source, I'll wait till that done first. So if we go to source, generate hash code and equals. And we're going to go age, name, and weight. So what it's going to do, it's going to generate an equals method. So the equals method is if they're the same object, it's going to return true. Yeah. So, and then it checks to see if they're not the same age, if they're not the same name, if they're not the same weight. Okay, so just click on generate. I'll go back to it again. Boom. So you go to source, you go generate hash code and equals, and generate it down here. Make sure you have age, name, and weight. Generate. Now, this produces something as well called a hash code. Now, what a hash code is it produces a now what hash code actually does is this produces a unique number for every object that's created. That's what it does. Okay? This produces a unique number for every object that's created. Now, it's not on the exam. And to be perfectly honest, hash code, if you want, there is whole books, there is whole courses. You could spend your whole life doing just these guys. Cryptography. cryptography is hash codes. All right, and you know how big cryptography is? Cryptography is changing your message into some sort of unintelligible garbage that no one can make head nor sense of. All right, so a hash code, that is a way to produce a kind of unique. Now it should produce a unique number for each object you create. Okay. Now you can call this anywhere. You can call hash code in any method you want, and it will produce a unique result for every object. Okay. Now the equals method can use hash code. Okay, because the hash code is produced. If you just look into it, I'm not even going to bother explaining it because I have to explain these guys here, and they're called least significant bits, and we don't need to know this sort of shit for now. Okay, if you look inside of here, it's using the age, the name, and the weight to produce a number. So, dependent on what you create your cache with, it's going to produce a hash code. Do you understand that? So it's using the age, the name, the weight, and also a random number. All this guy here is producing a random number, basically. Okay, so it's using the age, the name, and the weight, and a random number to produce some number that's going to represent your object.
So PPS number was created like this, except like random number.
Yeah. But the thing about this is, using this hash code in reverse, if you know the number, you should get all the details of your cat.
But like you said, so like it's a random number added to this, so like
It's not really a random number. Okay, it's what they call a pseudo random number. Okay, so if you just run this in reverse, you can change that guy back to a cat. Let's say we create a cat with it's 2. It's got a name of Tibbles. It's got a weight of 2.3. You can use this number to recreate our cat. Okay, so the hash code, it's more than just a password to an object. It can recreate the object as well. Okay, it doesn't matter how complex. Now, the more complex the object, the more complex your hash code is going to be. It might be still just a number 456, but how they got to that number, there could be literally thousands of calculations going on inside. Alright, so hash codes are usually, in this case, they're produced by the age, the name, the weight, and it's doing something here with what they call a pseudo random number. Alright, now here Eclipse is overriding the equals method. Right, so the way it goes is this refers to the cat that's calling the method. OBJ refers to the cat that was sent to the method. Okay, so we'll call the two cats. The cat that's calling it, we'll call it Tom. The cat that's been sent to it is Tibbles. Okay, so the cat that's calling it, we'll call it Tom. The cat that's been sent to it is Tibbles. So that means that Tibbles is OBJ. Yes? Okay, so this refers to Tom. So if Tom is the same as Tibbles, return true. So if the two cats refer to the same object, it's going to return true. If Tibbles is null, return false, because you can send a null object. You can actually do that. Alright? You can send a cat reference to a null object. You can actually do that. Right? So if Tibbles is null, return false. Alright? So if the class of Tom and the class of Tibbles is not the same, return false. Now get class, that will get the class of your, so if this is a cat and if this is not a cat, return false. Do you understand that? So if they're both not the same type, return false. So that's checking Tom, that's checking Tibbles. Now, if we get to that point and it hasn't returned true, or it hasn't returned false here, or hasn't returned false here, then we know at that point. Now we know that Tom is a cat, because a cat is the only one that can call this method. Okay, so if Tom and Tibbles are the same class, if it passes this test, it means that Tibbles is also a cat. Do we understand that? So what we're doing here is we're creating another cat. We're creating a cat reference to Tibbles. Okay, we're creating a cat reference to Tibbles because Tibbles up to this point is an object reference to a cat object. So what we're doing here is we're creating a cat reference to Tibbles. So that means we have access to the age of Tibbles. That means we have access to the weight of Tibbles. Up to this point, we do not have access to the age, or we do not have access to the name, or we do not have access to the weight of Tibbles. Do you understand that? Okay. So, if the age of Tom is not equal to the age of Tibbles, return false. If the name of Tom is null, so what they're saying there is if Tom has no name, because that is possible, all right? You can create a cat that's got the name is a string, and a string can be null. Okay, so if the name of Tom is null, and if the other name is not null, then it's returned false. So what they're checking for there, if Tom's name is set to null, and if Tibbles' name is set to null. Now, I'm not going to bother explaining the rest of it because, do you know what? We don't need to know it yet, right? Because we do come back to the equals method. Now, so it's checking the name, then it's checking the weight. Okay? If none of those prove to be different, it's going to return true. So what this equals method will do is that if you've got two different cats, however, if they have the same age, if they have the same name, and if they have the same weight, it's going to return true. Do you understand that? Now, Java 2, that's a whole section. Equals and hash code is the whole section Java 2. In your one here, Malagupta does a book on it as well. It's a whole chapter in the book. Alright? And it goes into really minute detail with it. Particularly to do with these things. And these things. These are called bitwise operators. Alright? These are called bitwise operators, which we're not going to look at. Okay? Yeah. Now you can have a fag. Alright, just to test the equals method of the cat class, I created two cats now. These are two separate cats. That's the age of the first cat is 2, the name of the first cat is Tom, the weight of the first cat is 2.3. The age of the second cat is 2, the name of the second cat is Tom, the weight of the second cat is 2.3. Alright? Now, I go cat 1 equals cat 2, goes to the equals method. It sees that they're both cats. It sees that they're not the same cat. So it goes through all of the checks. It goes through all of the checks and it sees that they both have the same age. They both have the same name. They both have the same weight. They're both cats. So it will return true. Okay? Now, if you had a unique ID for each cat, that will return false. Do we understand that? Okay. So if each of our cats had a unique ID, it will return false. So if I for instance, if I just to show what I mean, if I create a equals method inside the dog class, okay, so there I have, is that the right, yeah, okay, so there's the equals method of the dog class, and it's checking the dog ID. Okay, the dog ID is going to be different for every dog, so that means that it checks this ID.
So we cannot get like equal dog because ID
Well,
changing.
in this situation, we can't get an equals dog. Okay, no two dogs are going to have the same ID. We have set it up in such a way that no two dogs can have
But
the
let's
same.
say if you will tell like triples equal like new name, let's say boss equal triples.
Yeah,
So it will be equal, yes.
with the cat, as long as it's the same age, weight, and what's the other one? Age, weight, and name.
No, with the dog.
With the
If you
dog,
tell like let's say boss equal
Spot and
triples.
Rex, yeah.
Yes. No, it's two different
Dogs, yeah.
But actually, if you will tell like boss equal reps. And
Yeah,
after that
oh,
you
yeah,
will
well,
check
then that's return true, yeah. Yeah. If they're the same dog, it's going to return true. Okay? So, if they're the same dog, it's going to return true. Now, you could make this equals method a lot easier. All you have to do is check the dog IDs. Okay? If you check the dog IDs, now that's neither here nor there. That's the equals method for the dog class. Is that okay with everyone? Okay. Now, so I checked out the two cats. It works. Okay. So it's returning exactly as it should. I'll just change one of these numbers. It's false. Okay. So it's working exactly like it said it should. Right. Now, I want you to quickly create an animal class. And I want us to have class cow extends animal, class sheep extends animal, class pig extends animal, class Frisian extends cow. Class Frisian extends cow. Okay? So we've got animal class, we've got a cow class that extends animal, and we've a class Frisian that extends cow. We've class sheep that extends animal, we've class pig extends animal. Yeah? Okay, so make sure you have that structure. I don't need anything in any of them. Right? Now we'll go back to main. Now, outside of the main method, but still inside the main class. So just go outside here. Go static void take animal and we'll just go here. Oh, sorry, I should go, sorry, in here, I should go animal, my animal. and type of animal is, I'll put in here, SYSO, I go my animal dot get class dot get simple name. Now this guy here will get you the name of the class, but what it would actually get you is com dot android dot, let's say, pass animal. Okay, I just want to get animal. So what we're doing here, we're calling get class. That's going to get the class, but it will get you the full name. com.android.animal. Got simple name will just give you animal. Everyone okay with that? Yeah? So what will this method do? Put it in here above it. Get class will get you the full name of the class, which would be com.android.animal. So we call another method on get class, get simple name, which will just get us the name of the class animal. Right, so my animal dot get class dot get simple name. Now, so this is our method. All right. Now we are going to create us a. We're going to create an animal. Animal nd is equal to new animal. We're going to create a cow. Bessie is equal to new animal, or sorry, cow Bessie is equal to new cow. We're going to create a Frisian. Fred is equal to new Frisian. Sheep. Flossie is equal to new sheep. And pig babe is equal to new pig.
What's the Frisian?
It's a breed of cow.
You go as much time as
Ah?
lunchtime we do for a tour.
Oh yes, if you want to see Frisians. See cows. I know a woman once she was from Dublin. She was on the phone to me and she was talking away, and she was walking through the country at the time. She said, "Oh Jesus, what is it?" I knew the fellow that was with her. And she said, "Oh, there's some sort of big dog looking at me." And your man, give me the phone. No, it's a cow. So, oh, it's a big dog looking at me. It was a cow. A Frisian, to be honest. Right, now, so, static void take animal, animal, my animal. Now, this guy here, okay, this can take either a animal or a subclass of animal. So this thing here can take Andy, Bessie, Fred, Flossie, and Babe. Okay, so when a method, right here, when a method can take a superclass object, that means it can also take a subclass of the superclass. Now, the way to read it, Andy is an animal. Bessie is a cow is an animal. Fred is a Frisian. Frisian is a cow, which is also an animal. Flossie is a sheep is an animal. Babe is a pig is an animal. So this guy here can take all animals, right? So it can take an animal object, it can take a cow object, it can take a Frisian object, it can take a sheep object, it can take a pig object, okay? So put it here. The method take animal can take a animal object or any subclass of animal. It can take a superclass, by the way. That can't take an object. Okay, so it can take a subclass of it. So that means I can call take animal ND. I can go take animal Bessie. I can go take animal Fred. I can go take animal Flossie. I can take animal Babe. There it is. So type of animal is animal, the type of animal is cow, the type of animal is sheep, the type of animal is pig. Okay? So when you have a method that takes a superclass object, that means it can take a subclass of that object. Everyone okay with that? Yeah? Now, so we'll go back to our dogs. Alright? So we'll just have a look at our dog class. So we can see that Lassie has an age, a weight, and a weight. Okay, each dog has an age and a weight. Now we can't change the ID, but we can change the age and the weight. Yes, everyone understand that? Yeah? Okay, so now we do have a dog called Lassie. So I'm going to give Lassie an age of 2. I'm going to give Lassie a weight of 4.5. Okay. Now, I'm going to create a number called change num. And we're going to say that's 200. Okay. Now, so I am going to, so I'll just write this up here because I won't be able to see it. So the age of Lassie is 2. The weight of Lassie is 4.5. And we have something called change num. It's just a number. It's 200. Okay, there's the 3 figures we're going to be using. Now, so what we're going to be doing is we're going to be passing the dog into a method. We're going to be trying to change various things with the dog. Okay, we're going to pass in a number to a method. We're going to change the number, and we're going to see is the change reflected outside of the method. Okay, we're going to see does the age of Lassie change, does the weight of Lassie change, does what Lassie refers to, does it refer to the same dog. Okay, so we are going to create another method. Okay, and the other method is going to be called change value. So static void take animal. Oops, sorry, hold on a second. So again, put another method beneath take animal. We're going to call this static void change values. And it takes a dog, we're going to call Spot, It takes a number. Actually, to make things easier, we'll call it less. Now, so dog less. Now, inside the method, okay, what we're going to do is we're going to change the age of Lassie to be 9,000. Okay, I'm going to do a print statement. I'm going to say inside method age is and I'm going to change the weight of the dog is equal to 100.23, and I'm going to say SYSO inside method weight of Lassie is now also inside the method the number we have sent to it. I'm going to change it to a high number. I'm going to change it to 7800. Now the dog that Lassie refers to so just the ID of the dog is Lassie.dog ID. Okay, so I think Lassie is an ID of 5, so it'll print off ID of the dog is 5. Yeah, everything so far? Yes. Okay. Now inside the method, what I'm going to do is Lassie is going to refer to a brand new dog. And to prove it, Lassie inside method ID is I go Lassie.dog ID. Now, so what we're going to do is we're going to send our number, which is 22, to this method. So I'm going to call the method. I'm just going to scroll up the screen for a minute. Okay, I'm going to scroll up the screen for a minute. So now it's called change value. So I'm going to go to before I sent, so SYSO, before method call, I'm going to say SYSO, age of Lassie is Lassie.age, weight of Lassie is Lassie.weight, and the last one, ID of Lassie is Lassie.dog ID. I'm going to call the method. The method is called change value. Is it change value or so change value? I'm going to pass it to Lassie and change num. Okay. I should have done up here as well. So hold on. That's why I change num as well. Change num is N. And then I'm going to go SYSO after method call, and I just copy all those guys and paste it after it. So what I'm doing is I'm checking the age, the weight, the ID of our dog. Then I'm checking the number, all right, before I send them to the method. Then I send Lassie to the method, and inside the method we assign a new age to Lassie. Inside the method we assign a new weight to Lassie. Then we attempt to assign a new dog to Lassie. Okay? That means if the change is accurately reflected, that means that outside of the method it'll be a different dog ID here. Okay? So we just want to see the changes we make inside the method, are they reflected outside of the method? Okay? So, come off. So this we'll start off with. Lassie.age is 2, Lassie.weight is 45, change num is 200. Right. So we have before method call, age of Lassie is 2, weight of Lassie is 4.5, ID of Lassie is 7, change num is 2. So before we send them to the method, everything is fine. Now it goes into the method. Changes the age to 9,000. So inside the method, so this is the same, this is the dog. So inside the method, the age of Lassie is changed to 9,000. So I get here. Inside the method, we change the weight of Lassie to 100.23. Okay. I change the number to 7,800. Okay. Now we can see that inside the method, ID of the dog is still 7. Okay, it's still the same dog. Okay, on this line here, we change it to a new dog. So that means Lassie inside method ID is, in this case, 10. Do we all see that? See what's happening? So all of this, so changes the name of the dog we sent to it, goes 9,000. Inside method, age of Lassie is 9,000. Change the weight of the dog. Inside method, weight of Lassie is 100.23. Num. Should I put a little there? Inside method, num is 7,800. Oops, sorry. Okay, so let's print them all off. ID of the dog is 7. Then it refers to a brand new dog. So up here, Lassie inside method ID is 10. Okay, so we,
Why did you go from 7 to 10?
because I created when I created Spot, I created 2 dogs after him. Okay, so goes to 10. Now, so inside the method, the age of Lassie, initially we changed it to 9,000. The weight, we changed it to 100.23, and we changed the number is 200. Now we change, and also I assigned it to a new dog, so that means it now has an age of 0. It should now have a weight of 0, and it should have an ID of 10. Alright, however, what actually happens is the following. Scroll up here. Now, after a method call, when you send an object to a now, maybe I didn't say this before. When you create an object, right? So let's say dog spot is equal to new dog. A bit bigger. So dog spot is equal to new dog. Now, the main difference between references and, well, there's a couple of differences. One of the main differences is that an object only stores the address. So when you go dog spot, that's only the address. That's all that is. Okay? So that is only the address. If you're a primitive variable, that's storing the actual. So if you have int num is equal to 45, num actually stores the value 45, whereas dog spot only stores the address where that guy is. It's in a particular part on your machine. Okay. Now that means when you send an object to a method, you're not sending the actual object itself, you're sending the address of the object. When you're sending a variable to a method, you're actually sending a value. Okay? You're sending a value. Now, that means following. If you send an object to a method, you can change the attributes of that method. So you can change the age, you can change the weight, because if you scroll down here, if you scroll down this one here, after method call, the age of Lassie has changed. Okay, the age of Lassie has changed outside the method. The weight of Lassie has changed outside the method. Now, the only thing we can change is the ID. Now, to prove it's the same dog, it still has an ID of 7. Okay, we try to reassign to a new dog inside of the method. You can change what the dog refers to, but you can change the age and the weight of the dog. I can't change the ID because it's fine. Yeah, so you can see that the age and the weight is changed, but it's still the same dog. So if you send an object to a method, you can change the attributes of the object, but you can't change what the dog actually refers to. So if I send spot to a method, what comes back is spot, but it can be a dog with a different age, a dog with a different weight, but it will still be spot. Okay, so we can see here, this is still 7, still the same dog. However, if you send now, check that out again. Okay, if you send a primitive variable to a method, so outside of the method, this variable was 200. I sent it to the method, it became 7,800. Outside the method, it's still 200. Okay, because that's called passing by value. When you pass by value, a variable is a value. If you change inside the method, it's not changed outside the method. If you pass in an object, it's passing it by the reference. You can change the attributes of an object, but you can't change what the object refers to. Is that okay with everyone? Do we understand that? So I'm going to put in this comment here. Okay. When you pass an object into a method, it is passed by reference. Actually, I should put above that. A object reference does not store the object itself. All it stores is the address of the object. So think about, we'll create a person object, the person object lives in Merview. That's it, that's exactly it. So it's the address, Noel lives in Minna, Ballinasloe, County Galway. Okay? It's not the actual value itself, it's just the address of where the object is. Okay? When you pass an object is passed by reference, this means that if you change the attributes of an object in the method, the attributes are also changed outside of the method. In this case, we change the age and weight of the dog inside the method. The age and weight is changed outside of the method. If we pass an object into a method, we cannot change what that object refers to. If we pass in Lassie to a method and inside the method we assign Lassie to a new dog, outside of the method Lassie still refers to the original dog. Okay, what proves it is ID of Lassie before the method call is 7. ID after the method call is 7. It's the same dog, but it's got a different age. It's got a different weight. Okay, is that okay there, everyone? So when you're passing in objects, as you'll see later on now, that's very, very useful. Alright, so you can pass in an array list and change all the things in an array list. Alright, now, so that is that section finished. Now I did an awful lot more. That section is actually only 2 pages because a lot of things that's not included in that, so I included in this. Is that okay, everyone? Okay, so I'm just going to go back to the book and just go over the points that might be useful. So I'll open up her up here. This won't take any more than 2 minutes. So page 106. So 106. The variables in Java can be categorized into 2 types: primitive variables and reference variables. In this section, along with a quick introduction to reference variables, we'll cover the basic difference between reference variables and primitive variables. Reference variables are also known as object reference variables or object reference. Okay, so either means next page. Now, so an object reference is in fact a memory address that points to a memory area where an object's data is located. Okay, so dog, spot, that's an address. Okay, that's not the object itself, which you should know by now. New dog is the object. Yeah, so the object is actually new dog. That guy there is just an address where the dog lives. Dog Spot, he lives in Merview. Dog Spot, he lives in Roscoe. Okay? That's what that means. And that's the actual object. Then she goes on about here. Now, so, as you should know this, that's the type of object reference variable. That's the name of the object reference variable. This is the operator used to create a new object. This is the actual object. Okay, so this is the object. This is the reference. The reference on the left-hand side, the object on the right-hand side. Okay, actually what's happening in this one here, I suppose this is handy. A new person object is created. Okay, that thing. A variable name person is created in the stack. Now, the stack is just a place where objects are created. Okay, think of it that way. Okay, if you're creating 1,000 objects, those objects are created in something called the stack. All right, that's all it is. It's just a place in memory where your objects are created. That's all. Okay, so a new person object is created. That's the first thing that happens. The second thing that happens is that a variable called person is created. All right, so that's the first step. The second step is that is created. Okay, and as soon as that is created, it's automatically assigned the value of null. All right, so the person object is created first. Second thing that happens, it creates a person reference, and that person references a null. Okay, references a null. Next thing that happens is that this reference is assigned to the address of this person. Okay. Third thing that happens is that the person reference is assigned to the address of where this person is living. So that's the 3 steps. Now, do you absolutely positively need to know that? I suppose so. Doesn't make a difference really though. And on the next page, it gives a terrible explanation of objects, so I will ignore it because it's really, really bad. It's about a dog on a leash. Alright? One object can have several references. That's what they're trying to say there. Okay? You can have a dog called Spot. You can have a dog. Now, I call the dog Spot. My next door neighbour calls the dog Rex. My wife calls it, which I don't have one, but let's say if I did, called it Lassie. It's all the same dog. Okay? Reference is just different name. And that's all it is. Okay? As well as reference having a different, as well as the different name references, you can have references of different type. You can have a superclass reference to a subclass object. You can have an interface reference to an object that implements it. So you can have something like animal, my animal is equal to Spot. That will only show us the animal characteristics. Sorry, take out that guy. That will only show us the animal characteristics of Spot. I can go dog, my dog, my dog, the Spot. That will show us everything. Spot is a dog, so that will show us everything about Spot. Let's say Spot implements the behavior interface. Behavior B dog is equal to Spot. That will show only the methods from the behavior interface that Spot implements. Okay, so references allow you to only see certain things of an object. Okay, interfaces in particular, that's what they're all about. They only reveal the side you need to know. If you want to get your dog to run across the screen, you don't need to know about whether it's happy or sad. If you want to calculate the wages of Andrew, the accountant in our accountancy department, I don't need to know how he moves. I don't need to know his family situation. All I need to know is his financials. So you can have an interface that does explicitly with his financials. Okay. Next page. Now, the default value for all types of object reference variables is null. Okay, is null. Now, what I mean by that is, if I have a dog class and I have a person owner, okay, by default, that's going to be null. Okay, just like a string. So the default value for objects is null. Yes? And the next page. Now, so the basic difference is that primitive variables store the actual values, whereas reference variables store the address of the object referred to. Okay, so that's the basic difference between variables and primitive variables. Also, at the end of the day, every object is ultimately going to be made up of primitive variables. Okay? Primitive variables you can't break down any further. Objects you usually can break down further. Is that okay there, Rob? And then she goes on the next page about the differences between between primitive variables and object variables. It's no harm to go through each one of those yourself. But that is that section finished. Okay, so you can go to your lunch now, folks. Okay. So I'll stop that video and I'll save it.